All right. Well, thanks for joining. Let's go ahead and get started then. Uh, so I took a look at the itinerary, and it looks like we're doing a trees interview.
A tree, yeah. Like to
Okay.
practice tree, yeah.
Okay. Cool. What level and role are you interviewing for?
The basically is like a software engineering test, some kind of SDET kind of
Okay.
role, yeah.
Okay.
Yeah, so there's a programming component, so I just want to
Right.
practice. I think tree and graph dynamic programming. Those are my something that I'm not strong. I'm not really good at, so I want to get more practice in those areas.
Okay.
Yeah,
That's something we can definitely do today.
sounds good.
For the level, or I guess in terms of years of experience, are you looking for a more experienced role or more
More
entry?
experienced role. Experienced role. Yeah.
Okay.
Yeah.
Gotcha. Cool. And how many interviews have you been have you been doing so far?
None right now, but you know, I mean the job market right now is not very good.
That's correct. Yes.
But I do want to prepare that and also I also want to maybe try internal transfer first within my current company.
Okay.
But they have the same interview process, so I do need to do the same same type of preparation for interviews. Yeah.
Okay.
Yeah, you can see my screen, right?
Yeah, I can see your full screen.
Okay, sounds good.
Okay.
Sounds good.
Cool. So will Python 3 be the language that you want
to
use?
Python is there because I use it word. So yeah, okay.
Sounds good. Why don't you go hit the run button, see that the interpreter works correctly?
Yeah, looks. Yeah.
Okay, perfect.
So
have you used this editor before in the past?
The last, last week I have another. I had another coding interview, so that I used that last week.
Okay.
So yeah, but yeah, so before no.
Okay, I see. So if you want to try different Python things, you can always test the editor here. You write your code and comments here.
Yeah.
And you can also type in the chat as well here. So that's a couple of things that you can do during this interview.
Oh, okay.
If you want to test something, but you don't want to write it out.
Oh, I see. Yeah, I haven't used the chat feature last time, but okay.
The chat's
that's good to know. There. Yeah, that's good to know. Okay.
Okay.
Sounds good.
So let's go ahead and get started. I have one input here where change quotes. I'm going to put everything in quotes actually. So I have one thing in as my input. It's going to be one string, and I want to return and the string will represent a file path, like if I did pwd in the current directory in terminal.
Okay.
I would get something like this. If I want to know the file structure of it, such that the output is nested in the this adjustment. Okay, so the output would be nested such that the subfolders would be beneath the parent folder, and two spaces would mark the parent-child relationship between the folders.
Okay.
So because we have a header inside of components, header is two spaces behind components.
And then it's hierarchical. Okay.
Exactly. So components is under app. So there are two spaces underneath app. But since header is two below app, we have four spaces.
Interesting. Okay. So okay, gotcha. Okay. So okay. So each level there's a indentation, it's like a two spaces, right? I see. Okay. I gotcha. So is that possible to pass an empty string?
Yes, yes, it is possible.
Okay. So if it is empty string, I would think, so basically you're going to return an empty string, right? Because
Yes.
okay. So it's that, can I assume that all the input follow this pattern? I mean, there's a slash, um,
Yes. Yes. You can
and
assume that.
there's a slash, and also is number allowed? Like, for example, header 2, mix of um, uh, integer and
Yes.
character.
Yes.
Yes. Okay. And is there like I have to? Does any constraint as to where to put the number? So I can start with a number, or is there a constraint regarding the
No, you can treat the numbers as characters. As
number
regular.
as a character? Okay. How about space between each?
No
Say
spaces.
no spaces. Okay, sounds good. No space, but allow integer. But integer is treated as a character, right? So in the string. Okay. Okay, sounds good. Okay, so the input. Okay, so the input. Okay, I think so maybe I just brainstorm my some potential solution, then start code it out. One is I would split the string based on this delimiter and put them in some kind of list. Then use a for loop to traverse the list, and then when I print it out, each element of the list are print on a separate line and with two more indentation. Let me see, two more indentation in front. So I think basically this is like two minus sign, right? And is there space between two minus sign and?
Yeah, there's one space.
Oh, there's one. Okay, there's one space. There are two space here. Okay, I see. So there are two space here, then two minus sign, one more space. Then the okay, then the word and okay. So that's gonna be yeah. So yeah, I think that's seemed to me that let me see if there's some other example. Okay, let me write some other examples. Each level, can that be all numbers, like two come 3, and header 5. But okay, but you said the integer would be treated as a character, so I would assume all numbers is also possible because this is just treated like another string, right? So yeah, I think that's what I'm gonna do. I'm gonna just split this string with a slash as the delimiter, and put the result in a list, then just simply just traverse the string, traverse the list, and then just print the desired output format. That
What would be your runtime?
That would be okay. So Yeah, I think that's if the I would say the average word length is, let's say n is the average word length. I would think, yeah. So word length, n is, it doesn't matter. I think it's number of element here. It matters. So let's say m is the m is if m is the, let me see, m is number of folder layer there, number I yeah. So I would think that the time complexity is just OM, right? You just traverse the whole list, and the space capacity would be the space it I mean the list occupies, which is m times n. Yeah. So if but let me see. O n. So if there's an m word, so it kind of n times. And if the space is up, it's gonna be m. There's m words, each with n length, so m times n. Yeah, So I think that's I think that's the time complexity I can think of. Yeah. So do I just go ahead and code it up, and then I can use some example to verify my my algorithm.
Okay.
So, okay. Traverse, I don't know what it calls. Give it arbitrary name. I guess it doesn't matter. I just give it arbitrary name. So, so it just pass whatever that is. So I just pass in the string. So first I just split it. So how do I know how many? Okay, so we just split it into list. Okay, so if I split it into a list, and then get the length of this list. Just do, and actually I don't even need this. I don't even need this variable. Okay, I just traverse so that soon, and then I traverse this. Traverse this. So maybe I put in a result, which is empty string. Okay, so this is empty string. So the first, maybe I should have a counter. Let me see. maybe I should have a counter. So, okay, so, right, return. So if I equal to, okay, so if I can traverse that, the first, let me see, okay, first array. So I always put dash dash into the array. So each line I should, okay, so each line results I should, okay, so add a dash plus one space in between plus the, okay, I think L is the list, I is the index, so plus the word at I position, and okay, so let me see. Okay, then iterate to the next one. I think I need a append character return at the end. So there are two space. So okay, so let me see. I should. Let me see. I should. Let me try some. I think I need to append something. So I times 2 times okay, so times of space. I think I can do that, right? Give me what? Give me this. I'm not sure if I can do this here. So okay, so let me try this. So can I do this? 2 times I think I can, yeah, I can do this. So, okay, so the space, there's one space, two space here, times the index, times 2, just one space. So, times 2 times index. So first time there's a 0, so it's gonna be nothing here. So times, okay, next, then once you finish everything here, then you just return the results. Okay, so what if the string is empty string? I think if the string is empty string, we're not getting to inside here. It should just return empty string. Okay. Let me call. Oh, wait. Not return. I don't think I need to return anything, but I do need to print this out. I do need to print this out. Okay. Then I don't need to return anything. Okay, let me call this T. Let me call this. Okay, so okay, first get an empty string. So you split this into 3 words, less words. Okay, so let me try one. Let me see. So let's go to Okay, so let me try this. Split. Let me try this. Yeah, good. Wait. Ooh. What? Why there's an empty? Oh, I think, okay, so they're possible. It's empty. So if element is empty, so I need to check if the current element is not empty. So, okay, so I need to make sure this is not an empty string. If that's the case, okay, so yeah, okay, so then I can skip the rest. Okay, so then every time at the so I printed leave some space. So each line I add 2. Okay, so then add minus sign, add a space, the element of this thing. Okay, so then I construct the big string, then print it out, then return. Okay, let me try an example here. See if I can print anything. Oop, wait a minute. I thought I print a character return. Did I just, okay. All right, that's something. I think that's 2 space, app, 2 space, components, 4 space header, but at least work for one example. Let me try the empty string here. Okay, I need to plot this. Okay. All right. Okay. All right. Okay. Let me also try. There's just one layer. Let's see. Okay. Let's try there's only one layer. There's no slash. Let's see. Yep. Cool. All right. There's no space allowed. Okay. Well, it cannot be that straightforward. I think that is something I use. Yeah, I think I printed wanted to. Yeah, 2 space here. Yeah, app, components, header. Yeah. Okay, print some. All right, so they're gonna be in my test cases. Okay. Okay, so I tried empty string. Okay, let me try to mix some numbers. Okay, let me. Yeah.
Cool.
4.
So
yeah, look good to me. Less.
So in this case, how many spaces do we have?
Say it again.
First. How many spaces do we have?
Oh, wait a minute. You're not supposed to print. Oh, I see. So, I see. I cannot use the index. I have to use some kind of counter, because what if that's what if there is some I skipped some empty string, so I cannot just use, maybe I use a J here. Yeah, you're right. Maybe I use a J here instead use, so only when I add something, I just increase this. Otherwise, I'm not going to do anything. Okay, let me try that again. So if I use another counter instead of so I'm only going to increase the counter if I actually, there's something useful. Okay, so okay, so, and okay, let me try the let me try this one. Did I do? Yes. I think, yeah, I think that, yeah, that was wrong. It was corrected. Okay, so count 3, yeah, count 3, yeah. Let me think of any more corner cases. So empty string is a space within the word is not allowed. So I assume when you say no space, I mean either at the front or at the back, at the end, or in the middle. It does. There's no white space allowed, right?
Let's say that the input won't involve having to deal with white space.
Say that one more time.
The input won't have to deal with using white space.
Okay. Sounds good. I'm just trying to think of the possible corner case, or edge case. Yeah, so I think that's correct there. Yeah, so, maybe there's, yeah, so,
Right.
yeah, yeah, I think that's empty space, only one layer, multiple layers. Yeah, I think, what is there any other example I can think of? Mixed number, and yeah, I think, what if, no space? So that can be the edge case. Yeah, I think that's all I can think of right now. I don't know how that relates to trees, but
Okay.
yeah,
Well, this is just the first part of the problem.
Oh, okay. I see.
So the next part is how we're gonna try to relate this to trees a little bit.
Okay.
Okay. So the thing is here is that what we want is to have a program that can take in files and then print the entire directory. So let's say you're in a library or something, right?
Mm-hmm.
And you want to know. Actually, a library is not too good of an example. Let's say you're in a company and you want to get it's a small enough company that you can list all the people that work there.
Okay.
And you want to you can add people, and when you add people, you can also see everyone that works there, and it'll include the hierarchy being the boss, employees, stuff like that. So instead
Go ahead.
instead of just printing, we want a couple of commands here. We want something like add. It would be add A, B, and C. And then if we do like another add, do like A, B, D. and then another add with, let's say A, D, no, E, F.
I'm not too sure the definition of add. Add to what? Add to the.
It would add to our containing directory. So
containing directory. Okay.
So like we would have something like this: directory, 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 and then if we did directory dot print or directory out, you can make up whatever name you want, and we would get A, B, C, E, E, F.
C.
So in this case, right, we still have the same hierarchy as before. B is inside of A, so there's the 2 spaces.
Okay.
C is inside of B, so there's 2 spaces. But the thing is that B also contains a D as well. So D is inside of B. And so we have 2 spaces here.
I see. Okay.
And then E is inside of A, so we have 2 spaces here. F is inside of E, so we have 2 spaces here.
Okay.
So we have these 2 functions. We add and we print.
Look like a directory is like an object or something. We need to define a class for that, or
yeah. So it'd be like a directory equals something like this. You can call the class however you like.
Okay. Foo is the class. Okay. So directory is okay. So so directory is the just instant of that class, and in that class there's a method called add. Right? So okay, basically okay. So AE. Okay, so it need to figure out the hierarchy. Okay, so I see. So it needs to figure out the hierarchy. So A is inside, E is inside A. Okay, I see. Then F is inside E. Okay, basically use that to So use the indentation to print basically the file system. So basically the hierarchy. Okay, I see. I see. Okay, we need some data structure. So do I assume the class already exists, or?
No. Please define.
I need to implement. Class. Okay, I need to implement. Okay.
Implement the 2 functions as well, add and print.
Okay, I see.
And for print, you don't have to return the string. You do like what you did with before, where you just called print.
Okay. Yeah, so print should be straightforward. Okay, so maybe let me define it here. So, okay, objects. Okay, so got the syntax of this class. So okay, so there's a foo. Okay, there's so there's a construct. So okay, so so the add and is a string and print with nothing. Okay, so there should be okay, so there's a new function. So Okay, so I don't think it passing anything. The constructor doesn't pass anything. Okay. All right. So, what data structure do I use? Previously, I just used a list, but I don't think list. I don't think list would work in this case. I don't think list would work in this case. I need to figure out would a stack or queue work in this case. So first, I don't think how do I maintain that? Okay, so okay, so let me think of. I don't think that's add. You can split it, but I need to store it somewhere, right? So I need to store. So okay, I see. So okay, wow. Okay. What data structure do I use? I can use no. Okay, so I can break it down and what data structure. What data structure do I use? Wait a minute. So okay, so data structure that I use. So lists will not work. So if I put them into a list, if I add, okay, so add.
Could use a hash map.
Oh, use a dictionary. I mean, in
A dictionary.
yeah. So but if I use a dictionary, so, but how do I maintain a hierarchy in the dictionary? So okay, I can use the letter as the key, but the next level, is simple. Okay, so it's dictionaries. No. Okay, so how do I maintain a hierarchy? So if I use a dictionary, okay, so if I use a dictionary, so if I use a dictionary, so if that dictionary, this is the key. So I have to use like a dictionary out of dictionaries or something. So that I can maintain the hierarchy. Oh, complicated. So 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 if I use dictionary, okay, so directions. But if I use dictionary, I don't get to. I don't have to. So if I use first, okay, if I use first name, so if I use, so if I use, okay, so if I use the first, so if I split it into a list, okay, if I put it, so if I use the letter, use the word as the key, then, how do I, so, okay, I still have to split it, but, still have to split it. But after I split it, there's gonna be a for loop. There's gonna be a for loop, right? Okay. So that's gonna be a for loop, and can I imagine? So, dictionary. So I have to make sure that it's not an empty string. So as long as it's not empty string, then I should add to the dictionary. Okay, but wait a minute. Even I use this word as the key. What do I store as value? So do I store the remaining of the list as the value, or do I, okay, so what if I store the remaining of the list as a value? Then how do I figure it out?
Can we put the dictionary inside of a dictionary?
Yes, that's what dictionary of dictionaries.
Okay.
But the problem there is, okay, so so if I put a dictionary of dictionaries, so then, so first, I need to check if, so I need to check if it is not, okay, so if it is not an empty string, and also the, okay, so maybe I just brainstorm, I just maybe, or try to come up with a solution, then try to simplify it later. So the optimize later. So, but let me, so this might be a key. So I need to check if this is in the key of dictionaries. If it is, I don't see a for loop will work here. So, maybe use a while loop. So basically, okay, this I equal to 0. So I have to smaller than the length of the list. So if, okay, so if this current element is a key, if it is a key, so then if that's the case, then I would just put the I'll put the remaining of the list. I'll put a remaining of the list, which start from remaining of the list starting from I plus 1. So the current is the key. So then the remaining Okay, so if it is already there, okay, so if it is already there, but okay, how do I find the proper location? Okay, how do I okay, so if this already, so if it is already, so if this is the key, so then the remaining should be okay, but the remaining, how do I break it down to the, okay, so how do I break it down to, okay, so how do I break, okay, so if this is the key, how do I make the remaining, then the next elements probably as the key of, if this is already the key, so maybe, okay, so now, how do I put it into the, okay, so maybe how does this, maybe do, true, so it is, I think it is a true.
Can you tell me what sort of problem you're running into?
Right. So I don't think the way I'm doing right now is the right path, because if here I'm say in this example, okay, let's just take one example, right? So if I'm here, right, so A, so A is, let's say A is already in the dictionary. So then I should look at the next element, which is B and C, and it should be and this should be in, because each value of correspond to a key in the dictionary is also another dictionary. So I need to put B and C in the right place in that dictionary, right? So they're going to be because if I want to keep this hierarchical, I need to not only have dictionary of dictionaries, right? I need to have multiple layers of dictionary. So it's going to be dictionaries of dictionaries of dictionaries, right? So that's why I think it's like I think I think this is kind of a dead end. Maybe I should try another. Maybe I should try another data structure or another way to put the each folder in the right place. So if assuming dictionary is the right data structure, so I need to figure out a way to put each folder, right? In this case, A, B, and C in the right location of that dictionary, right? But I just I don't think the way I'm doing right now is the right way.
So the problem is having to reference the inner folder, right? Let's say you already have an inner folder that already exists, right? Is that the issue?
Inner folders.
Let's say we do ABC for the second part, and then ABD for the next part.
Yeah.
Right. Your A exists, so you go into B. B exists. How do you go into it? Right?
Yes, but actually, I'm not there yet. What I'm stuck with is how do you put ABC into the right location of that dictionary. Okay, assuming the dictionary is the right data structure. So
you should think of it recursively.
Right. Okay.
So in essence, remember how I walked through.
Okay.
How I can walk you through. C is inside of B. B is inside of A.
Okay.
If our A is our root, what if B was our root? Right? Then we would think of B as the root. Then C would be a child. D would be a child. And it would be no change in our logic. There's no significance in A that makes it the root than B.
When you say recursive, you mean recursive at the method level, or recursive? When you say recursive, you're talking about this method
as in nested in the
data structure.
The data structure.
Okay.
And then also that you can call the method within itself.
Call the method within itself. Okay. So if I do this recursively, so basically I can add this recursively until I reach the base case. Okay.
Right. Add would take in a helper. Could take in a helper.
Okay.
Right? And that can update your dictionary. And then you call the helper with both the dictionary and the string.
Okay. Is there an iterative approach?
Yes, there is.
I would prefer
okay.
Based on
iterative.
So
we can do. When you talk a little bit about that, iterative would be exactly the same, except instead of recursing, we would just use 2 pointers.
2 pointers. You mean one at the front, one at the back of the?
Right. We check to see which one is in the not the front of the list. We would check to see if the essentially we would check to see if the next value is present, and if it's present, we set a pointer to our parent, and then we set the other one to the current value, and then we have that same pointer and we keep referring to that parent pointer.
Okay.
But then, as we're referring to our parent pointer, we do our logic on the inside. Okay. So it'd be like a 4i in range L.
Okay.
If I of that index, if L of that index in current pointer.
Okay.
Then we would set that pointer to the directory.get of Li.
Okay.
And then, or we would set that to itself, essentially.
Okay.
And then we keep calling it until we reach a point where it's new, and then we would make a new direct dictionary, and then set our pointer to that value. Okay. And keep running until we go through all of L.
Okay.
We could also do this recursively as well. I feel like recursive would be a little more cleaner.
Yeah. Just curious, is this a question from LeetCode or
yes, this is a question on LeetCode. So the LeetCode question is actually here. This is a Google phone screen. I actually got this question for Google as well.
Okay.
So this is the exact question I got. So they use A, B, and C. The exact question I got was this. And these are off by a bit, so I need to fix those. But yes, this is heavily tree based in the fact that we can use them for recursion.
Okay.
So one good idea of this is recursive DFS. DFS is basically taking a graph, turning it into a tree. And
So-
we only visit the nodes we visited before. So you can turn it into
So
a tree.
recursive, is that top down or the approach is it a top
This is
down
tail
or
recursion or
tail
tail.
recursion? Okay,
This is top down.
top down.
Yeah, because we're
Okay.
going from our parent and we're checking to see if our children are present.
Okay,
And if they are, we go inside. If not, we create a new value.
I see. Okay, that's a very interesting question. I'll look at this.
So just to reiterate, though, a good way that we would do this would be to have some helper with some dictionary and the string. Let's see here, file. Then no, actually, files is a keyword too. So we check and we see if file is empty, if is and then if it is, then we just return. Otherwise, we would break it down. Phi.split, just like before, right?
Okay.
Break it down, or we could just have the string itself already broken down for us. We check to see if so we have like a pointer to dictionary, and then we check for I in F. So this would be each value, right?
Okay.
We check if I is in pointer dot keys.
Okay.
And if it is, we set our pointer the pointer dot get of pointer dot get of I.
Okay.
So that would take us into that value.
Okay.
If it's not there, then I would set pointer equal to dictionary. And then, or no, sorry, I would create a new dictionary and name that pointer of I. So this one would go inside, this one would do that. And actually we would do the same thing here too. So this clean, even cleaner, we would do this.
Yeah.
If not, then we create a new dictionary for that value, and then we go to that value. So now I have a pointer in there.
I see.
Then afterwards, we would call
helper. Okay.
Pointer of that value minus the value we're currently at. So
okay,
it would be like that, and then afterwards, actually we don't need to do this because we're doing this iteratively. We would go into we would set that pointer there, and we would keep on doing this for all of pointer. So at the end, dictionary still points to the topmost value.
Okay.
Right. We just return dictionary, or since we already have the values here, we could just call we could just call helper on directory and S.
Yeah. Okay.
And then directory would be updated, and that's all we needed to worry about.
Okay. Okay. Cool.
That's how we could do this.
Just curious. I mean, when you got this question from Google, did you? I mean, I figured they only give you 45 minutes, right? Did you get all of that, or you?
Yes.
Oh, okay. Wow. Impressive.
So for them, it was one question where we had this, and we just wanted to print it out.
Okay.
Here we have an add and a print, so we could change it a little bit more.
Okay.
this question is currently, I think it's still approved. So there's a good chance you might that this could still be in interviews currently.
Okay.
But yeah, in terms of the trees, one big part is each subtree also qualifying as a tree, and also building the tree by having an additional parent connecting to your current tree.
Right.
So there's a lot of tree and recursion go together.
For tree problem, do you prefer use recursion, or you it look like you prefer use recursion, right? But I think the test review, I think one of the instructors, going through the test review, that he prefer actually iterative approach for solving tree problems. I went through the notes for the live class. I think the template they give is like for the breadth first search tree, they use an iterative approach, but for the depth first search, right, they would use a recursive function. But my understanding is even for depth first search, you can use iterative approach as well. Right. So either way, right? So breadth first search, I'm not sure you can use recursive.
No.
Or not.
Use recursion there.
You can.
You can because you need to see your neighbors of the current value you're on.
Okay.
Depth first search is you can enact what you need to do directly. So there's DFS recursive, but there's no BFS recursive.
Okay. But usually I think recursion has a higher cost, is more costly, right? Because the cost stack and everything.
The thing about that makes it costly is space, because while you're calling all your values, you still have the function that called the function open in stack memory.
Yeah,
so
that's right.
Preferably, if you don't need to use recursion, don't. And it'll help you save memory. In the case that you have a very large input, you would break your computer with a Stack Overflow exception. So, but in this case, right, regardless of us using iterative like this or recursive, we're building our directory. We're not we're building our directory, and that will require space, and the same amount of space than if we were to do recursion.
Okay. Yeah. Any suggestions to how do I? Because I think tree is something that mixed with recursion. It's not something that I'm good at. So any suggestion as to how do I improve that, or it's certainly doing more lead code problem is one, but is there any other additional suggestions or advice or
for recursion? So
recursion and a tree.
Okay. Yeah. There's a couple of things for that. Let me pull up. This is like a really small study guide.
Are you printing?
I'm just looking it up.
Okay, sure. I thought you sent me something, but I didn't see it.
No, not yet. So here is one small practice on tree recursion.
Okay.
And then there's another. This guy, if you like reading more.
Okay.
This one that also talks more about tree recursion. Okay. So one is more text heavy, the other is more code heavy, I'd say.
Okay. Good.
Just look through those, and then afterwards, and they also are very Python-y. So
Sounds good. Sounds good. Thank you so much. Yeah.
Yeah.
Cool. That's a really good question. I think for me it's a little harder, but that's a really really good question.
Glad it helped. So one thing is a couple things for the debrief.
Okay, sure.
So in the case of getting your test inputs, very good in the beginning where you asked about what kind of inputs we can get. Definitely is good. Is good to mention all of those, and then also worrying about like special inputs like empty string spaces, and then walking through your code afterwards. It's good. All that's very good. A couple of things that I would want you to work more on is classes. So Python, Java, any sort of language, there will be classes. So they'll try to have classes. Try to have the notation match.
Try to what again? Sorry.
Have your notation.
Okay.
So when you create an initnef method, make sure that you have this.
Oh yeah.
The thing, right? And then
I wrote too many functions at work, so I haven't used class for a while. So
definitely it's good to refresh on that a little bit.
Definitely.
And then another thing is you can always take additional notes here. So in the case of being able to help yourself and help you sort of understand how to work around the nested dictionary a little bit more. You can always just use this place from scratch. So let's say you had something like this, 1 line 71. Just make this happen. Like we have this. It doesn't have to make sense, but since it's a code editor, auto tabs, you don't need to worry about. Then you can design your thing right here, so you can know exactly like what to do when you have a new value. You just create a new dictionary, so you just do this. This would match with that.
Right.
And then if you already have a value, then you would just set that value to the value that you currently have.
Right.
So that'll be this, and then you'll notice that we have an outermost dictionary as well.
Right.
So because we shouldn't directly add to it. It depends. If you directly add to it, then let's say I'm going to add one more actually, so that it makes sense here. Let's say I had A, B, C, and D, E, F, because we're not guaranteed that A will be the only root, right? If we did something like D, E, then F, then we would have to iterate over through all the keys here when we print.
Right.
We could also just have some value over here and then call with all the children when we print, so that we would print all the values like in the values, and we don't have to adjust our recursion here. But that's for the print section.
Sorry, the last part. What does the question mark stand for again? One more time.
Question mark is a sentinel node, and so it's a node that you will not print. So the idea here when we do print, right? The print portion. Let's just go over that real quick so that this is relevant.
Yeah.
And I'm just going to get rid of this. So the print works is we check if directory.values is empty or not.
Okay.
So I think this is not correct, and if it is, we just return. Else we would go through for all the values. We would print the value and then call. So actually, let me just do print directory. we'd call print value, and then we'd also do print directory on the nested version. So since we have this as this, okay, and then we would do print directory on directory value dot to value dot values, or it would be the value. Yeah, it would we can't use the key here. It would be this. So for each key, since the key is this value, is the A, we would print the key, and then we'd call print directory on directory.get of key. So it would be this portion.
The value of the corresponding to that key. Okay, which is which is a nested dictionary. Okay, so that's the recursive way of printing this. Okay.
Yeah, and then for print, we just call print directory, and then that would be something like this.
Okay, so print directory is like a helper of that. Okay,
right,
makes sense.
Taking directory.
Yeah,
then you'll notice, like if we do that on directory, then we would be missing the outer part. So like for A, we would only be having A.
Right.
So in order to get all that values out, we could either do a root, like have the some kind of question mark here, or we could have multiple, like a list, and go through each value in the list at the top.
Okay.
So that's there's two ways around it, but that way you don't have to customize your directory or customize your recursion. You include another node and then just iterate over the values.
Okay. Interesting.
That's for print. Actually, this would include your depth as well. So so it'd be print your depth.
So that determined how many space.
The spaces.
Yeah, makes sense.
Yeah, and then
now it told. Yeah. At the beginning, I try to associate. I try to figure out how that relates to a tree. Now make that now is more clear. Okay.
Okay.
Yeah. So it's depth first search. Okay, makes sense. Okay.
Cool. Oh, and also when you call print directory, you can start with 0.
0. Yeah. Absolutely. Okay. Cool.
Okay.
All right. Cool. Thank you so much.
Yeah.
Really appreciate it. The feedback. Really, really valuable.
No problem.
Okay. Thank you so much. Okay.